Hey, good afternoon, everybody. Welcome to our AAI Dimensional Modelling for Students, Student Analytics webinar. My name is Matt Feltham from Altus Consulting, and just by way of setting the scene, what we're going to cover off in the next hour, we'll briefly introduce who we are. We'll talk about what dimensional modelling is. We'll get into the dimensional modelling principles. We'll talk to the importance of having an artifact in your dimensional modeling kit bag called the bus matrix. We'll walk you through the Kimball bus matrix or the Kimball four-step design process. Then we'll have a look at some examples of how we would go about doing some dimensional modeling in the student analytics space. And then, time permitting, we'll get to some question and answers. So just from a housekeeping perspective, if you have questions throughout the course of the webinar, please submit them through the Q&A feature in Zoom, and at the end of the webinar, we'll get to answering those. So who are we? What are we about? So Altus Consulting is the largest privately owned data and analytics consultancy in the Australia and New Zealand market. We celebrated our 25th birthday just earlier in the year. We have over 150 staff across our offices in Sydney, Melbourne, Canberra, Auckland, and London. We're vendor independent, which means we don't sell software. We work with the technology stack that you have, or if you need our help in choosing a technology stack, we will choose what's best fit for your use case. We've also been fortunate enough to be winners of Best Place to Work for 10 consecutive years in a row. So what does our higher ed experience look like over our 25-year existence? We've done a fair bit of work in the higher ed sector, spanning across advisory services from data analytics, strategy and roadmap engagements, doing health checks and reviews. We've built data warehouses and data platforms to deliver analytics across the full student life cycle, as well as the other typical university data domains of research, IT, HR, and finance. We do regularly sponsor the higher ed sector. So the AAIR Forum, we've sponsored that every year since 2009. And there's been a number of other conferences we've sponsored that fall into this data and analytics space that we operate in. So to give you some context, in the Australian market, these are the universities that we have worked with or are continuing to work with. Due to our presence in the UK and New Zealand, these are some of the universities that we've worked in those respective markets as well. So that's who we are. So let's get into dimensional modeling and what it's all about. So to begin with, let's define what it is. So it's an architecture and data modeling technique for presenting data for analysis. And it has two key areas that it focuses on. First being the perspective of wanting to deliver data structured in a way that facilitates faster query performance. So that's the technical perspective. Then the business perspective, it's all about delivering data that's meaningful and intuitive to business users so they can analyze and interrogate it. So where does dimensional modeling sit? It finds its home in the data warehousing business intelligence sphere. So if we reflect on what data warehousing and business intelligence is all about, that's ensuring that the right data reaches the right people in the right format at the right time. This is where dimensional modeling plays a key part in making that objective a reality. So when we talk to business intelligence, I like to talk to it in the context of the business intelligence pyramid. So what we see here is we have at the base of the pyramid operational reporting or operational business intelligence. That typically comes from your operational system, so your student management system, your finance system, your HR system. That data is typically real time. So when reporting off this, we're getting real-time answers. So answers these questions of how many staff have we got working today, what's happening as of last minute in our business. And this sort of data typically resides in, as I mentioned, our operational source systems, which are online transactional processing systems or OLTP systems. As we move up the pyramid, we then get to our tactical BI. This is where we do more of our time series reporting and what-if analysis. So it helps us answer the questions of, what was our average staff turnover last month, to our sort of time period, year-on-year, month-on-month analysis. And at the top of the pyramid, we have our strategic reporting, which typically takes the form of scorecards and dashboards, and it helps us understand how our business is tracking against KPIs and our strategic corporate goals. And the tactical and strategical business intelligence typically resides in a data warehouse. So the reason why I've wanted to call that out is when it comes to modeling data, our operational systems and our data warehouse typically model data, in a different manner. So from an operational system point of view, the dimension or the data modeling technique that's used there is typically entity relationship modeling, and its premise and its design is around storing the data as efficiently as possible. It typically is capturing low-level transactional activity, and so it's all about getting the data in as quickly as possible. They're not typically designed for getting the data out. From a data warehousing aspect, that's where things differ. So dimensional modeling, that's where it comes into play. They don't typically design for efficient data storage. In fact, it's typically inefficient data storage, but they're designed for efficient reporting and analytical queries. So I think the takeaway here is that you can't really apply one model to both approaches. You can't have a model that's designed to be efficient in its storage and also efficient in its query processing. So by way of background, where does dimensional modeling really come about? So Ralph Kimball, the gentleman seated here in the middle of this picture, him and his organization, the Kimball Group, back in 1996, they came up with this concept of dimensional modeling, and a lot of the terminology and techniques that we see in dimensional modeling today, such as dimensions, facts, grain, bus matrix, star schema, these things were introduced by Ralph Kimball and his organization, the Kimball Group. So where does dimensional modeling sit in, I guess, the architecture of our data platform or data warehouse? The Kimball Group has this notion of backroom and front room. Backroom is the area that we don't typically see from an end user point of view. So it's where our source systems are being brought into our data platform by ETL or ELT processes. The design goals around that is get it in as quickly and efficiently as possible, so we have no or limited footprint on our operational source systems, and maintaining the integrity and consistency of the data. But the front room, which is where our BI applications get exposed to the data in our data platform, it's where our users are doing ad hoc queries, etc. That's where dimensional modeling finds its home, because it's presenting the data in a way that's meaningful to the business. It's organized by business processes. The data there is at the atomic and summary level, and it's focusing on these design goals of ease of use for the business, whilst also giving good query performance. So just circling back, what are our main drivers for dimensional modeling? So as I've touched on it, it's ease of use for the business, and it's about having performant querying so that our analysis and reporting is in a timely manner. That means our business users are going to want to continue to use our analytics platform. So that's dimensional modeling in a nutshell of what it's all about. So let's dive into what some of the key principles are around dimensional modeling. So the first concept I'd like to broach is this concept of dimensions. So what are they? So we can define it as the textual values and codes that define and describe a transaction. They're the things that help us answer the who, the what, the when, the where, the why, and the how. So if we were analyzing a retail sales business process, for instance, our dimensions would enable us to answer these questions of who is the customer, what did they buy, when did they buy it, where do they buy it, why do they buy it, and how did they pay. I often tend to like to refer to dimensions as the bywords as well. So if you're struggling with your dimensional modeling and what you should have as your dimensions when you're speaking to the business and the business process you're trying to model, If the business is telling you that they'd like to understand A by X, by Y, by Z, it's these bywords, the X, the Y, and the Z, they will typically be your dimensions. So here's our first look at what a dimensional model typically might look like. We've got our fact table that's capturing our sales process, and around the size of it, we've got the things that we want to then ask the questions around this sales business process. So being able to analyze our sales quantity and the dollar amounts by these things such as our store, our cashier, what the product was, whether it was on promotion, what payment method it was. These are the things that enable us to slice and dice our business process and analyze it in more depth. And that's where dimensions come into play. So let's look at what the anatomy of a dimension is. So there's actually 3 key elements, but I'll talk to 2 of them now, and the third one will come a little bit later. So this is a product dimension here, which appears to be capturing beverages. So our first element is our business key. Business key uniquely identifies each row in our dimension from a business perspective. Need to iterate that, it's from a business perspective. And typically, our business key will be also the primary key of our source system that's feeding the data into our dimensional model. The second element is what we call attributes, and this is where we actually have our textual values that give descriptions and they give context to our business process that we're interested in modeling. And whilst individually, they give us some descriptive value, collectively is where we get even greater value. And that's where hierarchies come into place. So hierarchies, particularly in our BI tools, allow us to drill up and drill down and even drill to detail. This gives us another mechanism of how we can actually analyze our data. And by combining our attributes, we can start to create hierarchies. So in this particular instance, we can see our product group can sit over the top of our product type, and at the bottom of our hierarchy is our product name. So just another way that our dimensions can add to our analytical capability by using hierarchies within our attributes. So the other aspect around dimensions is how do we track, or what do we do with data as it's changing in our source system? Do we want to retain those changes? Do we want to overwrite those changes? And there's actually 8 methods of dealing with how to handle changes in our dimensions. They're quite unhelpfully named type 0 through 7. I'm not going to go through all 8 of them. I'll cover off the first 4, but the most common ones are type 1 and type 2. So what is type 0? So type 0 is where data that changes in our underlying source system, we don't reflect that change in our dimension. So it remains static. Type 1, which is probably the most common, so the changing dimension type, is as a change occurs in our underlying source system, that change is reflected in our dimension, and it's just a straight update or overwrite. Type 2 is where we enter the realms of if we want to actually track historical change. So unlike type 1, where we're overriding change, as a change occurs in our underlying source system, what we do is we create a new row and we retire or expire the existing record that was there. And the way we deal with that is we typically would have from 2 date fields, an effective from and an effective to date. And as a change is occurring in our source system, we would retire or expire our existing record in our dimension to be typically 1 second prior to the date timestamp for when that change occurred in our source system. And then as we insert a new row for the new change, our effective from date becomes the time at which that change occurred in our source system. And our effective to date is some future dated date. Type 3 also deals with capturing change, but it takes a slightly different approach. This is where we introduce a new column for an attribute we want to track change on, and that column actually keeps the last change that has occurred. So as and when changes are occurring in our source system, our additional column here is only retaining the previous change. So you have current and previous in the type 3 scenario. The dimensions can then be categorized amongst a number of types. So first off is date and time dimensions. They're probably fairly self-explanatory. Your time dimension would have a row for every second of the day. Date dimension would have a row for every day of the year or the date range that your use case needs to cater for. And then we can extend on that by using the attributes that we talked about. So you may have attributes that give additional context and create hierarchies on your date dimensions. So you may have fiscal year, fiscal quarter, calendar year, calendar quarter, day of the week, day number of the year, these sorts of things. Role-playing dimensions is where we have the same dimension playing multiple roles in a dimensional model. So the date dimension is a classic example of that. In your business process, you may have multiple dates that you need to model. You don't create a brand new date dimension for every single date. You just have one date dimension that is role-played across all of those use cases. Another example of that may be an employee dimension where your employee is role-playing a manager and also role-playing the employee that manager manages. Moving on to degenerate dimensions, these are a little bit trickier. These are dimensions that don't physically or aren't physically created as a dimension because they have no real attributes to warrant the creation of a dimension table. So a degenerate dimension key is actually captured in the fact table, and that's all there is to it. They're typically things that uniquely identify a row. So they could be like an invoice number or a transaction number in a sales transaction, for instance. And they can be quite beneficial for tying back to your source system, particularly when you're doing data validation, your UAT process, etc., to ratify that the data you have in your dimensional model aligns with what's coming from your source system. We then have junk dimensions. So these are dimensions where we junk together quite a number of attributes. They're typically flags, like yes and no flags. The reason why we do this is rather than create lots of little dimensions that would only have a yes and no value across multiple categories, you would junk them all together into one junk dimension, which contains pretty much every possible permutation of all the flags that you have contained in that junk dimension. Final type is snowflaking. This is a concept whereby we create relationships between dimensions that's more in the third normal form data modeling technique. So an example of this is you may have a product dimension that has a product category, some product category attributes in there. You may choose to take that out and create a separate product category dimension that has a relationship between the product dimension and the product category dimension rather than off your fact table. So you start to get this snowflaking effect, this spider webbing out of dimensions, joined to dimensions, which is typically suggested that you don't do this approach, but we talk to what these types are because they do exist. Okay, so that's dimension. So let's drill into the next key principle, which is facts. So what are they? They're numeric values or measurement that represent a business measure. Typically, they're just numerical values. There may be number of students, sales volume, number of claims, claim processing time, etc. And our facts can be aggregated to form totals or averages, etc. So they're often, from a BI toolset perspective, they're referred to as measures or metrics. Just be mindful that what we're talking about here, facts are the actual metrics, and then they reside in a fact table themselves. So facts, probably quite confusingly, are the fields that are metrics within a fact table. So by way of an example, here we've got our operational source system that's capturing some sale orders, and we can see here that we've got some sales transactions. And in its purest form, this data that's being captured in this source system could be considered as an atomic fact, because in its purest state, it is as low as you can go as far as the information it's capturing. So if we look at this operational source system table, we can see here that these columns could be defined as dimensions. There are ways to slice and dice and analyze our numerical values, which in this case is the dollar amounts, which is what would be a fact in this particular scenario. So just another example here, a retail sales fact dimensional model. We can see all these numerical values. They are our facts. So fact tables can then be categorized across 4 different types as well. The most common one is a transactional fact table. This captures typically 1 row per event. So in our sales example, every single sale that's coming in is a sales transaction. It's just going in as 1 new row into our transactional fact table. Accumulating snapshot fact tables serve a slightly different purpose. If your business process is mapping a workflow or a life cycle where you've got stage gates or milestones along the way, an accumulating snapshot is the best way to handle that, as opposed to our transactional snapshot where we're just pushing in new rows all the time that typically don't get updated. In an accumulating snapshot, we typically would have 1 row for the entire instance of the workflow. And as that workflow moves through its various stage gates along the way, we're continually updating that fact record as and when those stage gates are hit. So it's 1 row continually being updated, whereas our transactional fact table is just inserting row after row after row with no retrospective updating occurring on it typically. The next type is periodic snapshotting. This is where we take a picture of the data at a point in time. This may be a daily snapshot, a weekly snapshot, monthly, quarterly, annually, whatever the use case may be. And so, in an admissions dimensional model, you might be wanting to do a daily snapshot so you can track as you're approaching your admissions closing cycle. You want to see how your admissions are ramping up as we reach that timeline or that deadline. The final one is a factless fact table, which is sometimes a little bit difficult to wrap our head around because there's actually no numerical fact in them. Factless fact tables typically are used to bring all of our dimensions together related to a business process that basically form the relationship of what that business process is doing. However, it's not untypical to create a fact in a factless table, which is typically a hard-coded 1, just so it simply simplifies the counting across that. You could do distinct counts across it to come up with a metric yourself, but it's not uncommon to hard code a 1 in a factless fact table as well. So just to recap, we talked about dimensions. They're the elements in dimensional modeling that give us context to the business process we're measuring. They offer these textual values, descriptors. They help us understand and ask the questions of the who, the where, the what, the when, the why, and the how. They're our bywords. I'm interested in analyzing something by X, by Y, by Z. And our facts, these are our numerical values that we're interested in measuring in our business process that our dimensional model reflects. So the next principle I want to touch on is grain. So what is grain? Grain is a term that is used to describe the level of detail contained within a fact table. They help us answer the question of how do you describe a single row in a fact table? And the grain becomes important because all the measures we capture in our fact table need to align to the same grain. So understanding the grain of your dimensional model is a key thing, which we'll touch on a little bit later. And when it comes to describing grain, it typically takes this form of 1 row per X per Y. So 1 row per line item on a bill from a doctor, 1 row per daily snapshot of the inventory levels for each item in a warehouse, et cetera, et cetera. So coming back to our sales order operational source system table, as we already touched on a previous slide, this is a transactional piece of data that is pretty much at the lowest grain. And when we have data that's at the lowest grain, That's often referred to as an atomic fact. And these are typically what we would suggest when you're doing your dimensional modeling. Try and bring in data at the atomic level as much as possible. The reason for that being is that you can then aggregate off that. You can build aggregated dimensional models or aggregated fact tables off your fact table that's containing data at the atomic grain. So as we can see here, that as we aggregate up, typically dimensions drop out. So in this particular scenario, we can see our salesperson order number has dropped out of this aggregated level. As we aggregate again, dimensions typically fall out of the scenario as well. Customer drops out, and we are now aggregating across customer numbers and order counts, etc. So the key takeaway here is that when it comes to aggregating data, we can always aggregate up from atomic level, but if you design your dimensional model that's already at an aggregated level, we can't drill down, we can't manufacture the atomic level data if you already go in at the aggregated level in your dimensional design. So the final two principles I want to talk about is business process and star schemas. So what's a business process? I think we're probably all pretty familiar, but it's a low-level activity performed by an organization. Some examples would be taking orders, invoicing, registering students, processing claims, receiving payments, etc. And if you're wondering, Matt, why are you even talking about business process? The reason why we talk about it is when it comes to dimensional modeling, business process should be the heart of it, and it's something that we will cover shortly. The Kimball four-step design process talks about this. So we need to not lose sight of this. It's very common to do so. And when we look at our dimensional model, which is should reflect the business process, it's often referred to as a star schema. And the reason for that being is that at the heart of our dimensional model, when we present it visually, is that you've got the fact at the heart and you've got dimensions around the side. And the notion is that the dimensions are meant to appear to be points on a star, which is why it's often referred to as a star schema. But it has multiple aliases. It can also be referred to as a subject area, business activity. But ultimately, it is a model of a business process, which is how it should be designed. So I'd also like to introduce this concept of conformed dimensions. So in our dimensional model, where you have dimensions that are shared across multiple dimensional models, these are called conformed dimensions. So in the higher ed space, a teaching period dimension, a student dimension, these are the dimensions that are going to be common across multiple dimensional models. And these are conformed dimensions. And where they come into their own from a powerful point of view is that it gives you this power to then drill across multiple dimensional models via the common dimensions. So I guess the caveat around this is be mindful that as you drill across multiple dimensional models via your conformed dimensions, that you need to make sure that the grain of those dimensional models are aligned, otherwise you'll start to get some unusual results. Okay, so we've talked about dimensions and we've talked about facts, but we haven't really talked about how do we link those up? How do we form the relationships between our fact table and our dimension tables? This takes the guise of a concept called surrogate keys. They're typically numeric in value, quite often auto-generated by our underlying database management system that our data platform resides on. We don't expose them to business users because they have no real meaningful value, but they're useful for formulating this relationship between a fact table and a dimension. So you might recall, if I ask you to cast your mind back to when we talked about the elements of a dimension, and we said there was two, or I said there was three, but I was only going to talk about two. So this is the third one. So you might recall we talked about the elements being the business key, which in this case is the product ID. And then we talked about the attributes, which in this case is the product name and more that aren't depicted in this diagram. Our third element is the surrogate key, which you're seeing here is highlighted as the the product key. And as you can see, it's numerical, auto-incrementing, doesn't offer any value to the business, but it's vital in how we then form the relationship between our dimension and our sales order fact table that we have here. So without a surrogate key, the way you would need to link the relationship between your fact table and your product dimension would need to be on the business key. So you can see here, in this instance, would be the product ID with these beverage codes. However, introducing a surrogate key means what we can do then is we can swap out that business key for our surrogate key, and we would do the same across our customer and salesperson dimensions as well. So our surrogate key also becomes our primary key on a dimension, and in doing so, it then becomes the foreign key in our fact table when we have our relationship between our fact table linking back to our dimension. So our product key here is the foreign, in the fact table is the foreign key, back to its surrogate key equivalent in the product dimension. So typically your ETL will handle the generation of your surrogate keys and obviously establishing the relationship between those two when it comes to populating your fact table. And as I've touched on, primary key in your dimension becomes a foreign key in your fact table. So just to sort of recap on the different keys we may encounter from a dimensional modeling perspective. So the business key in a dimension uniquely identifies a row in a dimension from a business perspective, keyword here being from a business perspective. Surrogate keys, primary keys in our dimension uniquely identify each row in a dimension table from a dimensional modeling perspective. And then when it comes to foreign keys, they're our surrogate keys in our fact tables that link back to the primary key in our dimension. So in this example here, we can see we've got a number of dates at the top of our fact table. We can see our FK notation here to depict that they're foreign keys linking back to our date key in our date dimension, which is the primary key and also the surrogate key. And then the same concept applies to our applicant key for our applicant dimension and applicant's application status key for our application status dimension. So why do we use them? So there's a number of reasons in no particular order, but it gives us optimal fact table design. So what we mean by that is typically our surrogate keys are integers or maybe big integers if necessary, but that has a small footprint from a bytes perspective as to how much disk space our fact tables take up. It also gives us optimal report performance, and given that they're numeric in value, they're good candidates for indexes, and indexes prefer that particular data type. But here's probably the most valuable reason why we use surrogate keys, and that is to isolate the fact table from changes to business keys. So if you cast your mind back to our product dimension where we had our business key of BEV001, BEV002, etc. If we were for whatever reason to change our operational source system, and those beverages in that operational source system had a primary key, which is our business key in our dimension, that changed to something that was 1, 2, 3, 4, rather than having to go and update every instance of 1, 2, 3, 4 in all of our fact tables, all we're doing is making that one change in our dimension table. And because we've got surrogate keys, all those keys in our fact tables can remain untouched. So it isolates us from changes to business keys. It also provides unique keys for consolidating data, dimensional values. So if you're bringing data from multiple source systems into a dimension, it gives us a unique way of identifying that. And the last one is around supporting slowly changing dimensions. So particularly for slowly changing dimension type 2, which, if you recall what I touched on before, is where that's the method for tracking changes, whereby every time a change occurs in our source system, we're introducing a new row in our dimension. So if we only had business keys, if we cast our mind back to our beverage dimension, our product dimension, where our business key was bev001, if for whatever reason that particular record we were tracking changes on its product type, if that changed type, we'd be inserting a new record into our product dimension. The business key would still be bev001, but we would be just changing our date range of when that's effective. So if we were using our business key to form a relationship between our fact and our dimension, we've now got multiple instances of bev001 in our dimension, and we're not going to know which one we need to use without then going down the route of applying additional logic to, look at how the date falls between our date range to do that. So using surrogate keys, as we would have inserted a new record into that dimension, we get a brand new surrogate key. So from a fact table point of view, that relationship would pertain to the relevant record as it was at its point in time for tracking changes. So it does support slowly changing dimensions a lot better than if we were using business keys. So the next thing I want to talk about is the Kimball bus matrix. Now, this is just to define it, it's a mechanism for modeling business processes and conformed dimensions. It's a key artifact that you should have in your dimensional modeling kit bag, and it should be used because it gives us a bit of oversight of all the different dimensional models we may have in our organization. So what it looks like is we have all of our business processes. In essence, it's a grid. So on rows, we have all of our business processes. On columns, we have the dimensions that those business processes need to use. So it looks a little bit like this. We've got this scenario whereby we've got our different sales orders, payroll, stock business processes on rows. We can see what dimensions those processes use. And straight away, we can quickly identify which dimensions are conformed dimensions, those dimensions that are used more than once across multiple business processes. So it is a high-level view of all the dimensional models, all the business processes that we may want to dimensionally model, but it also comes into its own because it offers additional benefits whereby it helps us in the prioritization type scenarios. So if we're unsure which business process to actually implement first, we might see that one particular business process has a number of dimensions that will be used by other business processes. So that might become a candidate to implement that first because we then get a lot of our dimensions built that we would need further down the line. It also helps to identify parallel development. So we can see here our sales and orders processes got exactly the same dimensions. So it may be a useful candidate to actually develop those in parallel because all the work will be done to simplify that process that covers off two business processes, two birds with one stone. So what might a higher ed bus matrix look like? So this is looking at the student life cycle particularly. So we can see on our rows, we've got the different sort of business processes that would occur within a student life cycle, and all of our dimensions, well, not all of, but many of our dimensions across the top. And we're highlighting which dimensions are required in each process, which quickly gives us a view of which dimensions are conformed dimensions. So benefits of doing it, we've kind of talked to the 2 points, the first 2 points here of helps with planning and prioritization, supports parallel development initiatives, also promotes the discussion for conforming data definitions and rules that will later support ETL activities. And also helps us identify data custodianship. So we can see across multiple business processes which dimensions are being used. It helps us identify what data is required across business processes and points us back to who's the owner of that data and who's going to be responsible for that data across our business processes. The bus matrix, an important artifact, something that needs to be constantly updated as your analytics platform evolves, but it is a vital tool. It gives us this high-level view of all of our dimensional modeling across our organization. So the next thing I want to move on to is our 4-step design process. So this is Kimball's 4-step design process, the 4 steps you should take when it comes to designing your dimensional model. The first one, most important one, is select your business process, speak to the business, understand the business process so you model it accordingly. Secondly, we declare the grain, we then identify our dimensions, and then finally we identify our facts. So as I've talked on about, speak to the business, make sure you understand the needs of the business so your dimensional model models that business process accurately. The other thing to be mindful of is it's all well and good to want to be able to analyze the business process, but if you don't have quality data or there's lacking data, you're probably up against it from the start. So let's just look at an example scenario. Got this online retailer has stock in various warehouses across Australia, and they need to know what their stock on hand is at each warehouse by the end of each day. So the first thing we do is we identify what the business process is. It's a daily retail inventory. We then identify what our grain is. So it's 1 row per day per product per warehouse. We then look to identify what our dimensions would be: date dimension, a product dimension, and a warehouse dimension. And then finally, we identify our facts, which is in this case, wanting to understand what the quantity on hand is. Once we've gone through our 4-step process, we're then in a position to actually build out our star schema, which would take the form of something like this. Got our inventory fact table with our warehouse date and product dimensions to help us analyze what our quantity on hand is. Okay, so that's dimensional modeling in a nutshell. It's been a bit of a whistle-stop tour. If we now turn our focus to student analytics. So if we think about our student life cycle, starts off with our student recruitment inquiry phase, moving on to application and admissions, then to enrollment, progression, graduation, and finally onto alumni. Across that entire life cycle, there's many opportunities for analytics to be taken. So from a recruitment point of view, we can analyze what our marketing campaign and our recruitment agent performance might be. In the application phase, what's our offer, acceptance, rejection rates, etc. In the enrollment phase, what's our FSOL headcount, what's our fees and income. As our students progress, we can understand what our student performance is, how satisfied they are in their courses or programs, what's our attrition rates. In the graduation sphere, what's our completion rates and what's our average GPA across our programs. And then when it comes to alumni, how employable are our graduates and how successful are they after their studies? So when it comes to dimensions in the student analytics space, universities have a great propensity to need to analyze student data across many realms. And this is just a handful of the dimensions you might experience in a dimensional model in the higher ed space. Hopefully some of these are resonating with you if you're currently doing dimensional modeling in your higher ed provider. In my experience working across multiple verticals, the higher ed space is at the higher end of the number of dimensions you will have in a dimensional model. So don't be alarmed if you're finding that you've got lots of dimensions in your dimensional model. So what I'd like to do now, we're kind of running out of time, is just quickly step through 3 different examples of going through the Kimball 4-step design process for 3 different business processes that we might have in the students analytics space. So the first one we're going to look at is student applications and admissions. So identifying the grain as 1 row per applicant per program per academic year. Some of the dimensions, not all of them, that we might be interested in is information about the applicant, what program they're applying to, what's their application status, what campus are they interested in taking that program at, what was their application channel, were they a direct applicant, did they come via a tertiary admission centre, did they come by a recruiting agent, etc. What was their secondary education institution and their highest level of attainment, and these sorts of things. The sorts of facts that we would want to measure this process by is what were our number of applications, offers sent, how many of those offers were accepted, how many declined, days from application to offer, how many days from offer being sent to there actually being an acceptance. From here, we can then move on to building our star schema. So you'll note here that we've got quite a number of dates from when the application received, sent, offer, response, when it was withdrawn, etc. They're all role-playing off our date dimension. Our institution dimension is being role-played for our secondary education institution as well as our highest attainment institution. And these are just a few of the other dimensions that might be relevant in this particular business process, plus many more that I couldn't fit on this particular screen. And depending on your use case, you may want to add quite a number of other dates into this process whereby you're wanting to track, what's the date it arrived with student admin, and then it left student admin, and then it was back with the student, and then it came back from the student, and then it was with the faculty, etc. If you go down that route, you then have this capability to have your metrics that are then tracking the performance of how well the administrative side of the application process is going as well. So we can see there's a bottleneck that's always stuck with this faculty, for instance, for X number of days. And the other thing is we talked about different fact types. The type of this fact would be an accumulating snapshot, because as and when the application moves through the different stages of the life cycle, we're constantly updating the different dates and the statuses. So, when the application received, there'll be no offer sent, no offer response, no withdrawal date. So those dates would only start to get populated as and when we meet that stage of the life cycle. The next one I want to move on to is unit level enrollments with our student progression business process. So the green here would be 1 row per student per unit of study per teaching period. Some of the dimensions we'd be interested in here is wanting to know who the student was, what unit of study they're enrolled in, what program that unit of study belongs to, the teaching period that unit was being taken in, what was their enrollment status, what their grade was. The grade dimension would have like every possible permutation of the grading that's available within your institution. And then finally, what sort of facts would we be looking at here? So headcount, FSL would be the most popular common ones, but then we might be interested in understanding the fee amounts, how much of that is government funded. If they withdrew before census, how many days was it before census? If they withdrew after census, how many days that may have been after? And then what that star schema might look like is something a little bit similar to this. And then the next one I want to look at is student surveys. So surveying the student at the unit level, what their experience was. So identifying the green here, we'd be looking at 1 row per student per teaching period per unit of study per question. What sort of dimensions we'd be looking at here is so wanting to understand which student was taking the survey, which employee, which university employee was actually responsible for delivering that unit of study that their survey pertains to, which teaching period it was taken in, what survey type that might have been, the survey question, possible responses that they can have to that survey question, and then another dimension for capturing response comment if it was a free text type question. In regards to facts, well, response count, you could arguably potentially have this as a factless fact table where we're really only using this fact table to bring the actual response and question together, but you may want to understand which responses were answered or not. And this is what that particular star schema might look like. So in closing, what are the common mistakes that we typically find with people using dimensional modeling? So the primary one is using an existing report to design your dimensional model. You might have someone in a faculty come to you saying, here's a report I spin up in Excel. I'd love that to be fed out or provided out of our data analytics platform. You look at that report, you go away and build your dimensional model. Please, please, please don't do that. When this occurs, take the opportunity to remember the Kimball 4-step process. The first step is model the business process. Take the time to understand what the business process this particular person is reporting on. Once we understand it, we model it to match the business process and it gives best value to the business. Another common mistake is allowing operational source systems data model to dictate how you define your dimensional model design. Don't let your dimensional model be wedded to your underlying source system. When and if it happens, it probably will happen when you swap out your source system for another one. We've experienced that at multiple universities. All of this comes unstuck because it's too heavily wedded to your underlying source system. Model your dimensional model using business terminology. When you speak to the business and you're understanding their business process, use the business speak that they're telling you as how you name your dimensional models, all the attributes in your dimensional model, etc. The other one is neglecting to declare your grain and then complying with it. Key thing, make sure you understand the grain. If you're following your 4-step Kimball process to design your dimensional model, it is number 2 on the step list, so make sure you get it right. We've already talked to this one briefly. Don't use your operational source system keys to join your dimensions to facts. Use your surrogate keys. And then finally, not using conform dimensions. If you've got your bus matrix current and up to date, you'll be able to see what dimensions already are existing. Use them, existing dimensions where you can in your dimensional models rather than introducing a plethora of dimensions that are largely the same thing. Okay, so from a recommended references point of view, I strongly recommend you look at the Data Warehouse Toolkit by Kimball, particularly the Definitive Guide to Dimensional Modeling. Alternative to that, ALTIS has a pretty comprehensive data skills training program. Particularly, we do dimensional modeling. So if you feel that your organization or resources within your organization could benefit from going into a more detailed deep dive of what dimensional modeling is all about, we do offer a 2-day course. So if you're interested in that or any other of our data analytics offerings, please reach out to us and contact us. Here's our details. So we've got 3 minutes left. I might jump to our Q&A. Let's see if we've got any. Got one question that's come through, and I'll just read it out for the benefit of everyone else. I know you don't align yourself to any vendor, but what are some of the top ETL tools you recommend nowadays? So, good question. Depends predominantly on whether you're going down the cloud route or whether you're still on-prem, and ultimately it depends on your technology stack. We typically, if you're in the Microsoft stack space, the on-prem scenario is SIS, and then in the cloud you've got Data Factory as well, or if you really want to, you've got Databricks available to you as well if you don't want to go down the route of having the more drag and drop GUI where you've got a lot of tasks built for you. With regards to in the Amazon space, we typically, a lot of our clients we find are using Matillion as an ETL tool. In addition to that, ALTIS also has an offering which is called the Data Load Accelerator, which is pretty much does a lot of your ETL for you using straight up SQL, and you're just using an ETL tool for the orchestration. So we've got a number of clients that have embraced that. So beyond that, you've got your major players, which are Informatica, of course, but that comes with a big price point. Yeah, so hopefully that answers your question. Okay, last opportunity to throw any questions at me. Use the Q&A feature here within Zoom. If there's no other questions, thank you again for your time. I hope you found it somewhat informative. Once again, if we can be of help to you, get in contact with us. Thank you very much.